So you have a bunch of videos and you want to play them on your mobile device or on your smart TV, and they don't play that format natively. You might need transcoding. How the heck does that work? Welcome to Gadget Blues. This is KC, and today we are talking about media transcoding. Transcoding is the process of taking some piece of video and audio and playing it on a device that doesn't natively support playing that format of video and audio. Let's say you have a bunch of random media in different video formats that you've acquired over the years, and you have it on your Windows PC or on your network attached storage or elsewhere at home, and you want to play it on your TVs. There are a lot of different devices to choose from to play that back, and some of them may need transcoding, some may not, depending on what television you have, what the source and destination devices are. We're going to cover that here today. There are a whole lot of different devices for media on the market today. The market has never been more rich in choices, but that also means that it's tricky to choose which devices are best for you. And that goes for both the source devices, that is, things like network attached storage from industry leaders like Synology or QNAP, Thecus, Western Digital, Seagate, Netgear, etc., to playback devices such as Popcorn Hour, Amazon Fire TV, Apple TV, Roku. There are a ton of generic Chinese Android-driven playback devices, and some not so generic, like this one from Open Hour, which is a subsidiary of the Popcorn Hour folks. You might have a mini PC with an Intel CPU running Windows as a home theater PC, perhaps the NVIDIA Shield TV, a Raspberry Pi with an IR receiver, or maybe Amazon Fire TV Stick or Roku Stick. If you've seen my other videos with my wonderful cat, you know why there is white cat hair all over everything I have. Some of these playback devices require transcoding for almost everything. Others will play everything native, but may not support streaming services. And still others might support both streaming services and playing everything native. The best possible option is native playback, and that's playback that doesn't require transcoding at all. I say that's the best option because there's absolutely no quality loss from the source to the destination. You're playing the format directly at its native resolution without any loss of re-encoding. Anytime you have to re-encode something, all of the formats we're talking about, whether it's H.264, 265, WMV, or whatever, they are all lossy formats. That means every time you have to take that and encode it into another format, you are losing quality. That goes for both the audio and the video. For native playback to work, the player, and when I say the player, I mean both the hardware platform and the software application on it that are used to play back the video, have to have built-in support for both the audio and video streams in the original content. Native playback is very easy on the server side because all you need is a traditional Windows-style file share, which is called SMB or Simple Message Block. That means that there are almost no server CPU side requirements. You can use a very low-end NAS or any Windows machine to serve the content because it doesn't have to support media streaming at all. File share is all that it needs for native playback. Some examples of things that will do complete native playback of everything are the NVIDIA Shield TV and a Windows 10 home theater PC. If your player, combined with your display, can't play all the content natively, then you're going to need transcoding, which, as I mentioned earlier, is the process of taking a video or audio format and changing it to a different one or a different resolution. You will need transcoding to play a format on a lower resolution display or device, such as 4K content on a 1080p display or 1080p or 4K content on a mobile device. You'll also need it to support a format that is not playable on the destination device. A lot of devices don't support playing MKV containers, for example. a lot of smart TVs only support MP4, base H.264 codecs, and MKV is just unknown to them, so you need transcoding for that. What you don't need transcoding for is any kind of streaming video that comes to you over the internet, such as all of the popular streaming services, Netflix and YouTube and so forth, because all of those handle that themselves. Drilling down into some reasons that you might need transcoding, I mentioned that native playback, always the best option if you can manage that, but there are some expenses and additional things involved in that, which I'll get into later. But you definitely may need transcoding for mobile devices, because not only are those devices usually lower resolution, but you're going to need to downscale the bit rate in order to fit that over your cellular connection. You'll also need transcoding if you have what I call a limited streaming box. That's a box that is designed primarily to deliver Netflix and Hulu and so forth, and not so much to play your local content, such as a Roku or Fire TV. Those boxes are great in many ways, but they are designed to support a specific set of hardware and software codecs that are not the ones that most of your media are using. However, they do support the Plex client. Plex, if you haven't heard of that, is a combination server and client-side application that provides transcoding and media indexing, including metadata such as album art and all that other rich content. A lot of Plex users I talk to say they're using Plex because of family acceptance. They don't want to get another box in their home theater stack and another remote to deal with, so they run the Plex client on one of their existing devices, maybe even their smart TV, and have the server do the transcoding for them so everyone in the family can use the media that they have locally without using a different user interface. And that's absolutely great as long as you understand that you're going to get lower quality for that media than you would if you had a native playback device. A lot of older low horsepower players that were designed for 1080 playback are not capable of taking high bitrate stuff like 4K and downscaling it to 1080p. For example, the Raspberry Pi at $35 plus an IR receiver is a great little unit for running Kodi, which is the primary open source media playback UI. But the Raspberry Pi doesn't have enough horsepower to take 4K and play it on a 1080p TV. So if you have that situation where you acquire 4K content and want to play it on a 1080p TV, the Raspberry Pi by itself is not going to be able to do that, so you would need some kind of transcoding solution. And then similar to the mobile devices outside the home, you might need this inside the home if you have really lousy quality wireless networking. For example, you're in a very dense population area with a lot of conflicting Wi-Fi channels and you just can't get reliable Wi-Fi streaming. So you need to lower the bit rate of the content that's going to your TV in order to make that solution reliable. So to review the types of transcoding, there are, in general, video and audio transcoding. In the video side, you have transcoding between resolutions, like 4K to 1080 or 1080 to mobile. If the player device has enough horsepower, it can often downscale that, but some of them don't, as I mentioned with Raspberry Pi. Then the most common is between formats. Most of the smart TVs and so forth, as I mentioned earlier, will support a narrow set of codecs that they will play back. Normally, just only H.264 or MPEG-4, and they won't support MPEG-2, which was used on millions and millions of DVDs, or WMV, which is used in a lot of Microsoft content, or the new H.265, which is used for 4K, but is also getting widely adopted in the other resolutions because it's twice as efficient for bandwidth. And then you also need transcoding to go between containers. A container is a file format that has one of these codec types within it, but does not imply that codec type. In other words, MKV is basically a zip file that contains at least one video stream and then multiple audio streams. There are even free tools available to take an MKV and add and remove additional streams like you would with a zip file. AVI is another example of a container format from days gone by. It's not used that much anymore, but you may have a bunch of content that was using AVI as a container, and newer devices generally won't support AVI. Then audio transcoding. That normally takes place between different audio formats. We've got a whole bunch of competing audio formats on the marketplace, two major providers, Dolby and DTS, and then other open source alternatives like FLAC, MPEG, etc. Audio transcoding isn't the same as down mixing. Most player devices are capable of down mixing. In other words, if you have some content that has 7.1 audio and you only have a 5.1 speaker setup, either the player or your stereo receiver itself will be able to down mix that 7.1 content into 5.1. That is a lossless process that just involves combining channels. It's not transcoding. I mentioned earlier the term limited streaming box. This is just a term that I use to describe a box that was designed for streaming with local playback either not included at all or included as an afterthought or included only in a Plex client. These devices are limited in the codecs that they have hardware support for, and that's basically for cost reasons. They were really not designed for playing random content outside of the streaming experience. It's only the fact that the Plex client exists on these devices that makes them play local content. Most of these are very limited in that they will only support H.264 or in some of the new 4K versions of those boxes, the H.265 acceleration, and Dolby Digital Plus. From an audio standpoint, most of these limited streaming boxes support only Dolby Digital Plus for a multi-channel codec, and that's because Dolby goes in and incents them to do that so they can sell the decoder rights. And they will support regular PCM stereo, that's generic digital stereo, in addition to Dolby Digital Plus. But Dolby Digital Plus is used for any multi-channel content that you get from Netflix and so forth. Because these limitations are in hardware, you can't really get around them. You can't install a player that will play other formats directly. You have to use transcoding. There's no native support for a lot of formats like I list here, and that means that you're going to have to do all of that on the server side. One final note on streaming boxes is that Xbox and PS4 are really out of scope for this particular discussion, but I'll just say that they are kind of halfway in between a limited streaming box and a full-featured player. If you've already done some shopping for NAS that support transcoding, you may have noted that it is not across their entire product line. It's a premium solution, and that's because it's difficult to do. It's CPU intensive. It's the same work that the video took to create to begin with. And if you've ever used any software like Handbrake or Premiere Elements or things like that, you know that it takes a while to encode video even on a fast PC. It's also difficult because there are a whole bunch of different audio and video formats out there, many of which I've listed already in this presentation. And even within those formats, there are ranges of bit rates and different profile levels supported. So it's very difficult to make a generalization that a transcoding solution will handle every type of video that you throw at it. So transcoding can happen in a couple of different places. It can happen in the player, but that requires a player with a lot of horsepower. And generally, if you have a player with that much horsepower, say NVIDIA Shield TV, that is a player that can play everything natively, so it doesn't need to transcode. So for the purposes of this discussion, the transcoding really happens on the server side. And by server, I mean whatever is hosting the media that you're playing back. That can be a Windows machine running Plex server or other solution. It can be a NAS like the Synology QNAP, Tekis, Western Digital, Seagate, Netgear, etc. And there are a whole bunch of different solutions out there, and that's really what this video is to help you choose between. The processor in the server is really what determines whether you can transcode or not and what level of transcoding you can perform. I'll talk about transcoding levels soon. The NAS on the market, you'll see advertising transcoding. So it's a big feature that the NAS vendors talk about, and they will point out that this level of product will do no transcoding, or it will do 1080p transcoding, or it will be 4K ready. When something is transcoded by the server, the client gets whatever format it wants, and it doesn't know that the original format was anything different. So if you have a smart TV, for example, or running a Plex client, it will get H.264 if that's what the hardware in the smart TV is capable of playing back. In the CPU of the server, there are basically two classes of transcoding. There's what I like to call generic CPU transcoding that is done with the overall CPU horsepower itself, just as if you were running apps or whatever on a CPU on a Windows desktop. One will be faster than another. You're using the general purpose CPU capabilities. And then there is hardware assisted transcoding. That's on the next slide. So for generic CPU transcoding, the benefits really are that it's incredibly compatible. It can handle almost any format that you throw at it because it doesn't rely on a limited set of transcoding acceleration provided by hardware. It's done in general purpose software. And by general purpose software, I mean that software also doesn't have to go and support whatever specific hardware acceleration is provided by the platform. That is difficult for the developers to do. And that's why Plex has chosen not to support hardware acceleration, because it would be a tremendous amount of work for them to support all of the different platforms from all the different NAS vendors and CPUs from a whole bunch of different ARM variants and Intel and AMD and so forth, all of those having different APIs for doing hardware transcoding acceleration. So Plex server does not support hardware transcoding. That means that you need a really high-end CPU to ensure that Plex will be able to transcode everything that you throw at it. It needs to be a Core i series. You'll see a lot of NAS that say quad-core Intel, and when you drill down into that, you'll find that it's not a quad-core Intel Core i series, it's a quad-core Intel Atom. Those are lower power draw CPUs that are great for a power performance standpoint, but they don't have the horsepower to do general purpose transcoding. Some of them are capable of handling 1080p down to mobile. I actually had this really old Synology that was running an Atom, and it was not even certified for transcoding, but I found that in a lot of cases it would actually work at mobile resolutions, but your mileage may vary. And these horsepower requirements really mean that you probably should not expect to transcode to multiple users simultaneously. It's okay to transcode to one user while serving regular content to another user without transcoding. But if you want to transcode to multiple users, you're probably going to need a pretty high-end quad-core i7 to handle that without dropping frames for any user. The other type of transcoding is hardware-assisted transcoding. That means that the CPU has some extra special sauce that allows it to hardware accelerate the transcoding process. And that's usually done through a CPU that has onboard graphics, and they use the graphics processor not for graphics, but to accelerate transcoding. The benefits of this are that it's a heck of a lot less expensive because the CPU itself doesn't have to have a ton of horsepower. It offloads that transcoding activity to the special hardware acceleration. That can work even on ARM CPUs, which are even lower power than most of the Intel solutions. So very low power consumption, very affordable. But the problem is that the performance is not that predictable. You really have to kind of try it with your set of content to see if it will work, because when it's hardware accelerated transcoding, that hardware acceleration engine is capable of accepting a narrow set of inputs, that is specific codecs at specific bit rates and profiles that it will support transcoding. And if you feed it something that doesn't meet that set of requirements, it's going to have to do general purpose transcoding on it. And as I mentioned, the lower end CPUs don't have enough horsepower to do that as general purpose. So for example, what you would see on the NAS, if you ran within its operating system a CPU usage monitor, the CPU usage would be very, very low for content that it supports transcoding in hardware. And then the CPU usage would jump up to 95, 100% for content that it did not have hardware acceleration for, and then you would start dropping frames on the output most of the time. I don't mean to scare you away from these solutions. Some of them are very good. I just want to emphasize that you should probably try it on trial and make sure that you can return the NAS solution if it doesn't play the set of content that you happen to have. Hardware-assisted transcoding requires special software from the NAS vendor that has that code built in to use the hardware API provided by whatever CPU manufacturer it has. So it won't work with random software that you install. It will only work with the media serving software provided by the NAS vendor. And as I mentioned, it's not supported by Plex server. So for example, you would use the Video Station application. It's actually called Video Station on both Synology and QNAP. And the Video Station software would do the transcoding using the product's hardware acceleration. Hardware-assisted transcoding is much more reliable if all of your local content is homogeneous. In other words, you have encoded all of your stuff to one set of formats, say to H.264 with Handbrake, and it's all the same. That makes it very predictable. If you acquire some other random content later, it may or may not transcode properly. But if you have it all in one format to begin with, then that's more predictable than it would be otherwise. Because this requires a special app, in most cases, hardware transcoding will not work with DLNA. Windows as a server is an exception to that, but not a lot of people use that as a DLNA server. Luckily, the NAS vendors have mobile apps for their playback solution. So on iOS or Android, you'll be able to use their client, which will do server-side transcoding and serve you that content optimized for mobile bit rates. So let's talk about the classes of CPU that you might require to do these different types of transcoding. For 4K or really high bitrate 1080p, going down to 1080p or mobile resolution, you really need that Core i series CPU or a Xeon E3 or E5, which is the Xeon equivalents of the Core i5, i7 type of CPU. And for at least two clients, you probably need a quad-core version of one of those higher-end products. For 720p or lower bitrate 1080, you can generally get by with some of the lower power CPU solutions, such as the Intel Atom Avoton C2000, although those have a hardware problem where they're failing after about 18 months. So if you're buying a C2000 series, you probably want to look into the warranty situation. Or the new Denverton C3000 series, the Xeon D series, which is kind of halfway in between an Atom and a Xeon E3, or the AMD-R series. And you'll find that there are some CPUs even lower end than these I list that can get along depending on what your content is, how high the resolution and the bit rate is. If you look at the specs from the NAS vendor on which units support transcoding 1080 or 4K or whatever, they are basing that statement on hardware accelerated transcoding. When we talk about playing content from a NAS, there are actually 4 different ways at least that you can play back content from your NAS. There is the channel that is proprietary between the Plex server and the Plex client, be that a client on Windows or iOS or Android or your TV. The NAS vendor's proprietary software, like that Video Station software, talking to their client on Windows or iOS or Android TV. And DLNA, which is kind of a legacy protocol now that was developed for media streaming a decade ago and is supported by smart TVs and things like that. Then finally, of course, SMB shares. That's a traditional method of file sharing from Windows-style boxes, and it's supported by every NAS and every Windows, and it's very generic. It doesn't do any media transcoding or touch the media in any way. It doesn't even know that it's serving media. It's just serving files that happen to be media, and so everything happens on the player side with SMB. So you want a Plex server. Some notes about considerations that you need if you're setting up a Plex server. First thing to know is that you, one way or the other, are going to start accumulating 4K content from whatever source. Your phone can probably shoot 4K video now, and the next camcorder or DSLR or point and shoot or Micro Four Thirds camera that you purchase is going to shoot 4K video, probably at pretty high bit rates. And you'll also get various downloaded content from all sorts of different sources in 4K. So you're going to need to handle 4K. Whether your TV supports 4K or not at the moment, you need to have your server spec to be able to transcode 4K if you're running Plex, because even if you don't have it now, you're going to have 4K content sooner or later. And that leads into the beefy CPU discussion. So I mentioned the CPU classes that you really need to run Plex reliably. I think a quad-core i5, i7 or the Xeon equivalent is really the best way to go, because if you follow this Plex-ready advertising from the NAS vendors, you'll find that often they're saying a unit that has a low-end Atom core CPU, they're saying that is Plex-ready. Well, it can run Plex, and at low bitrate content, it might be able to struggle through at high CPU utilization. But if you want something that's future-proof, you're looking at a quad-core i5, i7 or Xeon. So the server side is going to be expensive on Plex. That means you need to balance the cost of the server versus setting up a solution where you can play the content on a native player like the NVIDIA Shield TV. Let's say you need to buy Shield TVs for a couple of TVs in your house. That's $200 a pop. But you're saving a whole lot on the cost of the server side, because if you look at what it costs to build a quad-core i5, i7 server or buy one from a NAS vendor, you may actually be better off cost-wise by getting a low-end server that just serves things via SMB shares, file shares, and playing the content natively with something like a Shield TV, because that takes the server CPU out of the equation. The reason you wouldn't want to do that is because of family acceptance. That means that they need to learn to use another user interface and another remote in order to run that native playback box. And Plex is often just right on your smart TV or a familiar UI that's an icon on your Roku or Apple TV or whatever that they can easily use. So look at the capabilities of your family for handling a different box and balance that against the expensive server that you would need to buy to build a Plex solution. Another option that really kind of covers all bases, and it's kind of a neat little way of looking at it, is to get both the native player and an accelerated transcoding NAS, such as a Shield TV and one of the Play series from Synology, which has a hardware transcoding engine built in. The CPU in those models is low-end otherwise, but it doesn't matter, because if you, say, put your Shield TV on your primary TV, you can play everything natively there, and then use the Synology client with transcoding to play the content elsewhere on your iOS or Android mobile devices or your secondary smart TVs if they support the Synology applications. And doing both of those at the same time is zero issue for the server, because it's only transcoding one thing and then serving the other via file share, which takes no CPU at all. So I think this is a really good combination. I keep mentioning Synology because really their video station package is very close to functionality with Plex server. It has built-in hardware acceleration, though, so it's got a leg up in that regard. It has the same kind of content indexing. It'll go to web-based content providers that will give it metadata, such as all the actors and the plot summary, the album art, the front of the DVD cover, and so forth on the screen. And all of that is very similar to the way that Plex works. That's why most of the time I mention Synology over QNAP, is because the QNAP Video Station app, while it checks the same box in terms of serving media and indexing, all it does is index the files just as files. It doesn't actually go out and get all of that rich metadata for them. And then Synology has their apps available across a really wide range of platforms, not just iOS and Android, which everybody provides, but also the Samsung OS used on the Samsung TVs, which is not Android, but actually a proprietary OS called Tizen, as well as an app for the Apple TV, for the Roku, and even for Windows 10. Then I've also mentioned the NVIDIA Shield TV a whole lot during this presentation. And the Shield TV is really the one box that combines so many of these different functions. So even if you have to teach your family another user interface, this may be the only one that they need to use besides tuning local channels through your cable box or whatever, because it supports basically everything that you need. It's got all of the major streaming services, Netflix and Amazon Prime, both in 4K with HDR. It has all modern video format native playback. It's got audio pass-through to your audio-video receiver or preamp processor for all of the modern audio formats, even the new positional audio stuff like Dolby Atmos and DTS:X, including their lossless predecessors, DTS HD, Master Audio, Dolby True HD. It has HDMI 2.0 with 4K 60 support and HDR, and the HDCP, High Definition Content Protection 2.2, which is needed to do the Netflix 4K and the Amazon Prime Video 4K. It's also relatively future-proof because it has hardware acceleration up through the new H.265 HEVC, which is the codec used by, for example, UHD Blu-ray. It also supports hardware acceleration of VP9, which is Google/YouTube's format for 4K, and that's become really important recently. It was kind of a side codec for a while, but recently YouTube has started encoding all of the 4K stuff into VP9, and so having hardware acceleration is really important for that. And finally, it not only supports Kodi, but it also has a special fork of Kodi called SPMC, which is not necessary to sideload or anything. It's right there in the Google Play Store for free, and it's written by a member of the Kodi team who is a real fan of the Shield TV. It's just the same as Kodi, except it has built-in support for all of their great hardware acceleration. So to summarize the classes here, basically we've got a low-power NAS without transcoding. That means you could use any kind of NAS on the market, all these different brands, or build your own with Windows or Unraid or FreeNAS or any of those kind of options. And that's the cheapest way to do file sharing, but you need to use it with a player that can play over the file shares natively like a Shield TV. Then that great option I mentioned a couple slides ago, the combination of the accelerated transcoding low power NAS like the Synology Play series plus a native player gets you kind of best of both worlds in terms of playing on mobile devices and playing with the highest quality in your primary TV. Then if you want to be absolutely sure that your transcoding solution will be able to play all of your media to any of your clients, then just throw CPU at it, get a high-end CPU quad-core Intel solution on the server side, and then you just won't have to worry. It's going to cost you more, but it's going to be able to play to any of your clients regardless of what formats they natively support. So I hope you enjoyed our discussion of media transcoding. At some point in the future, I'll probably compare and contrast all these different playback solutions and the different options that they support, because there are variations between these. Will settle things besides just what streaming services they support and whether they support Plex or not, and so forth. So thank you for watching. Please like and subscribe, and we will catch you in the next Gadget Blues.